Okay, so now let's go ahead and start looking at our notes page. A dilation occurs when you are enlarging or reducing a figure. All dilations will have a center of dilation and a scale factor that we call K usually. And I'm grabbing a piece of notes from last week just to remind you. It's a visual aid to remind you of something. We started talking about similarity. I said that they were misusing the term scale factor. If I have two figures and they're similar, okay, then if I want the ratio of one of their lengths to the other length, I can do it any which way I want to, but I have to tell you which way. I say, I want the similarity ratio of triangle ABD to triangle PQR, or from left to right, or from the larger triangle to the smaller triangle. I have to tell you the order, okay, for similarity ratio. Scale factor is a different thing, and it only happens with dilations. And scale factor is always in the exact same order. Scale factor is always the new length or distance over the old length or distance. That's why I didn't want to use it with similarity, because if you have two figures, like here, which one's the new one, which one's the old one? It's not a dilation, so I don't know. There's not a progression from one to the other. With a dilation, there is. So scale factor is always new distance or new length over old length. Okay, so let's talk about that for just a second. I want to go ahead and point a couple things out. Let's say I have a center of dilation here, and I decide I want to dilate that triangle ABC, by a scale factor of 1/2. Okay, now what I want to point out to you is this. We tend to think about the fact a lot that means the new sides will be half as long as the old sides. True. The other thing that you need to recognize, though, is that also means the new distance from the center of dilation is going to be half the old distance. All lengths will be half of what they are. And those lengths include the distance away from the center of dilation. So if I want to dilate point A, well, that's not going to be the best, but no, it's going to move along a line that goes from the center of dilation through A. And it's going to be halfway as far, if it's a scale factor of 1/2, it's now going to be half as far from the center, let's call it P, as it was before. If I move B, or when I do my dilation, B is going to be half as far as it used to be away from P. When I move C, the new C prime is going to be half as far as it used to be away from P. So all of my distances, all of my lengths will be half as much. So not only is A prime B prime half as long as AB, or A prime C prime is half as long as AC, but each point is now half as far away from the center as it was before. So everything having to do with length or distance has been multiplied by that scale factor, in this case being 1/2. Another thing, two other things I want to point out to you here with just this freehand dilation. One is points only move along a line that would go through the center of dilation. So if I draw a line through the center of dilation and through any point or its pre-image or its image, then the other stuff will be on there too. Like if the pre-image and the center of dilation are on the same line, then the image is on that same line, and so on. Okay? Or if I draw a line through any point and its image, that line has to go through the center of dilation. All right, final thing I want to point out to you here is that every single segment will move to a place or move in such a way that it is parallel to its pre-image or image. Okay? AC and A prime C prime, they're parallel. AB and A prime B prime, they're parallel. Anytime you do a dilation, the new segments are parallel to the old segments. Okay, so back to the notes here. The center of dilation is a fixed point in the plane. If the scale factor is less than 1, this doesn't really mean less than 1. What it really means is between 0 and 1. The dilation will be a reduction. It will get smaller. Okay, and we're going to say 0 is less than k is less than 1. We have a scale factor between 0 and 1, meaning it's a small number. If I multiply lengths by something like 1/2 or 0.6 or 2/3, they get smaller. That's a reduction. If I multiply lengths by something bigger than 1, 1.5, 4, even 1.1, they get bigger. So that would be an enlargement when k is greater than 1. Okay, now the reason, it's kind of splitting hairs, but the reason I said, it's not really, if the scale factor is less than 1, that I didn't want to say it quite that way, that I wanted to say it this way instead, is because scale factors actually can be negative. And the way that works is if I said I was going to dilate this by a negative 1/2, what would happen is it would be half as far from the center, but it would be over here. It would be on the other side of the center. So that's what would happen if I had a negative scale factor, which we don't usually have. Okay, just letting you know though. So when we talk about k being bigger than 1 and smaller than 1, we're talking about if we're all assuming that k is positive. In a dilation, the image is similar to the original figure. Not congruent. It's the same shape, but usually a different size. Usually a different size. The image is only congruent if the scale factor is 1. If you multiply all the lengths by 1, you get the same lengths. That would be congruent. The following coordinate plane shows a dilation of rectangle ABCD with a scale factor of 2 and a center of dilation at the origin. The result of this dilation is an reduction or enlargement. Which one? It's an enlargement for 2 reasons we can say we see that. One is you can't really see them very well, but if we could see them, we would see the primes on the bigger one. And we would say, oh, it got bigger. The other thing, though, is the scale factor. If the scale factor is 2, that is a number that is bigger than 1. So that's why it's automatically an enlargement. Okay, and the way we write the rule, sometimes called arrow notation, is you basically have x, y becomes, and let's do it in a more generic sense. Scale factor times x, scale factor times y. Now, let me point out that this rule only applies if the center of dilation is at the origin. Just like the rotation rules, we can only use the rules if the center is at the origin. That's why if it's not, we might want to move it there. Okay, one more thing to notice from this picture is that just like we were talking about with the one I did freehand over here, if I connect any point with its image or pre-image, that line is always going to go through the center of dilation. This one has a center of dilation at the origin. And that's why we said we can use this rule. So if your center of dilation is at the origin, or if you've moved it so that it's the origin, doing a dilation and knowing this, if you know the scale factor, is really easy. You just multiply everything by that number. Okay, next one. Dilate JKL using a scale factor of 1/2 and a center of dilation at 0, 0. So arrow notation, the rule would be xy becomes 1/2 x, 1/2 y. This is because they told me that the scale factor was 1/2. Is the dilation an enlargement or a reduction? It's a reduction because 1/2 is a number smaller than 1. If you multiply by 1, everything stays the same. If you want it to be bigger, you got to multiply by something bigger than 1. If you want it to get smaller, you multiply by something smaller than 1. So multiplying by 1/2 is going to make everything smaller. How can you determine if a dilation is a reduction or enlargement before you graph it? We just did it. We just said it's a reduction if your scale factor is between 0 and 1. It's an enlargement. I don't know why I did that last period too. I want to make my L into a T there for some reason. That's an L. It's an enlargement if K is greater than 1. Okay, so I'm going to take the coordinates here of J, K, and L. J is at 1, 2, 3, -3, 0. K is at 0, 3. And L is at 2, -2. I'm going to multiply all those by 1/2. So J prime is at -3/2, 0. K prime is at 0, 3/2. And L prime is at 1, -1. So I can graph it. So -3/2, 3/2 is 1/2. So here's -1/2, 0. Here's 0, +1/2. And here's 1, -1. So that's where my half as big figure will be. Again, all the segments are parallel to their preimage. So in other words, this is J prime, K prime. It's parallel to JK. K prime, L prime is parallel to KL. J prime, L prime is parallel to JL. Also, don't forget that not only are like J prime, K prime half as big, but they're also, all those points are half as far away from 0, 0 as they used to be. Half as far away from the center as they used to be. Questions to this point? All right, well, next up, we get to go to not at the origin. And we're going to actually, I decided I liked these notes enough for other reasons, excuse me, to keep them, even though I don't like this description, because that's not the way we're going to do it. So don't hold off 1 second. We'll see if I can find where I had changed it, because I did it very neatly. There we go. Now I have to do it again because I wrote all over it. Okay, so our step 1 is we're going to be shift the center to 0, 0. And all the other points too. Like, do whatever you have to do that to the other points too. We're not moving all the other points to 0, 0. So that wasn't the best way to phrase that. Sorry. Okay. How about, and move the other points too. So looking at the fact that the center is at -5, -5, to move that to 0, 0 means adding 5, adding 5. So this is what I'm going to do to all points. Sorry. Then step 2, we're going to do our dilation rule to each point. We're not going to say to the distance to each point. We're just going to say to each point because we've moved them now. Okay, we're going to do our rule for the dilation, which is basically, in this case, x, y becomes 1.5 times x and 1.5 times y. This is because I was told the scale factor is 1.5. And then I'm going to shift back. In this case, that would be -5, -5. So I tend to like to do this sort of horizontally. You can do it vertically, horizontally. If you're being methodical about it, you could do it totally unmethodically if you wish. But here's what I mean. I like to kind of go across. I like to take my points. So my points are E is 0, 1. F is -3, -3. D is 0, -4. First thing I'm going to do is my shift. And it's adding 5 to the X and the Y values for every point. Because that's what it takes to move -5, -5 to 0, 0. Okay, so that's 5, 6, 2, 2, 5, 1. So that's the shift. So this is where these points would be if my center were at 0, 0. Now I'm going to dilate. And if my center of dilation, sorry, if my scale factor is 1.5, that basically means I'm multiplying everything by 1.5. You could use an X, whatever's going to help you realize that's multiplication. Or you could write this rule there if you want. Okay, so this is 7.5, 9. This is 3, 3. And this is 7.5, 1.5. So we shifted so everything was centered at 0, 0. Now we've dilated, and now we just have to put it back where it's supposed to be. So my shift over here is always going to be the opposite of what I did here. It's also always going to be identical to the point that is the center. Because remember, the coordinates for a point are directions to get there from 0, 0. So to get back to where I'm supposed to be from 0, 0, I'm going to go -5, -5. And now I've got E prime is 2.54. F prime is -2, -2. And D prime is 2.5, -3.5. And that's my answer. So it's a 3-step process. It's just that you have to do it to each point. Shift it all, however it takes to get your center to 0, 0. Do your dilation, shift it back. Excuse me. Questions about this one? Let's go ahead and graph it. First, any questions before I cover it up? Okay. So E prime is at 2.54. F prime is at -2, -2. That's F prime. And D prime is at 2.5, -3.5. So I'm going to try and be as accurate as I can here. And that's just a vertical line. Okay, so we also should see the parallelness I was talking about earlier. DF is parallel to D prime F prime. DE is parallel to D prime E prime. FE is parallel to F prime E prime. It can help us check that we've done it right. Okay. Questions there? Okay, same thing happens again, but with a rectangle this time. On the back, it says there's a scale factor of 5 and a center of dilation -4, -1. Okay, I'm going to let you guys try this one. Okay, compare your work to mine. Okay, I said if the center is at -4, -1, that means I need to add 4, add 1 to shift it to 0, to 0, 0. Then I multiplied everything times 5. That's not 0.5. That's supposed to be like times 5. If you want to use an X, you can. Times 5. Then I shifted back. I did the opposite of what I did here, which is always going to match the signs here. These two will always match because you're going from 0, 0 to that point, and that's what point coordinates are. The directions from 0, 0 to that point. Okay, questions on that one? Notice that on this one, the center of dilation was one of the points, one of the vertices of the rectangle. So that point doesn't move because if it's 0 distance from the center, then you multiply the 0 distance times 5 or 10 or anything else. It's still going to be just as far from the center, which is 0. Okay. Now, you may have noticed this up on the board as you came in, those who are here, and we've kind of alluded to it before, and that is that if I am dilating, points only move. They don't just randomly move all over. They move along a line that goes straight through the center of dilation. So if I don't know where the center of dilation is, I can take any point and its pre-image or image, it doesn't matter which, and connect them on a line. And if I do that for more than one pair of points, sorry, let me darken it. If I do that for more than one pair of points, the one thing those lines all have to go through is the what? Center of dilation. So if I just connect points and their images a couple of times, or pre-images, and all of those lines will go right through the center of dilation. And so then I know where my center of dilation is. So that's how to find the center of dilation if you don't know where it is. You use just a fact about how points move with the dilation in line with the center of dilation to recognize that all these lines of the path that the point has moved must come together at the center. These 2 points, one move to the other. These 2 points, one move to the other. So that will happen. You'll be asked to do that. A lot of times, again, if we took the EOC, happens on the EOC. We talked about that here as well. If you connected B and B prime, connected C and C prime, connected D and D prime, connected A and A prime, those segments that connect those will always go through the center of dilation. And that's pretty much it for what's on your homework. Now remember,